People tell me if I have two things that are equal, as long as I add the same thing to both sides, or subtract the same thing to both sides, it's still equal. So, one of the reasons for doing this is I have a positive tension there, and I have a negative tension there. So when I add them, the tensions just go away. And what I'm left with is MdG sine theta d. That minus MAG sine theta A equals, that's the left-hand side. The right-hand side is M subscript A little a plus MdA. There are other methods of solving it, but that's just the way I tend to do it. We're solving for little a here, so we need to get a all by itself. In this case, I get factor, so if I factor it out, m sub a plus m sub b times g is equal to mvg sine theta b minus mag sine theta a. Oop, that should not be a g there. And then solve for a. I want a by itself, so I divide both sides by this coefficient. It cancels out over on the right-hand side, and I now have a formula here for my acceleration. And so at this point, it's plug and chug. Now, the point at which you put numbers in really depends upon you and what your mindset is at the moment. The general recommendation in teaching physics is to plug numbers in at the very end. There's definitely a distinct advantage of it if I've got a multiple part problem, but some students like plugging in numbers early just because they don't like writing the letters. There's nothing inherently wrong with that. In the end, it might cost you more work, but again, nothing inherently wrong. So if we plug in, I've got 5. What's 5 right here? 5 times, let's see what planet we can put this on. What, did I put the other one on a particular planet? Earth 1? That's 9.8 times the sine of
37. No.
the other one.
57.4.
Minus 3 times 9.8 times the sine of 37 degrees divided by 5 plus 3. Based upon just the physical nature of the problem, I know that it's going to accelerate in the direction, we picked the correct direction for acceleration. So B is going to go down that way, A is going to go up that way. So I expect the answer to be positive. The next bit is I expect that the acceleration is going to be less than free fall acceleration. So it should be less than 9.8. And the answer is $23.59.
No, I forgot to add.
I guess the top is 23.59.
7.72.
All right, I must have misheard. The top, the numerator was, did you say 23.59?
Yes.
The denominator is 8. And you got what at the end?
2.95. Yeah.
Say it again.
2.95.
2.95?
So meters per second squared, meter per second squared.
Yeah, it's acceleration. Because we are starting out in the MKS system, because we're using kilograms, meters per second squared, and degrees, well, we could have done radians also, but because we started out in the nice units, our answer should be in the nice units, which would be meters per second squared. Questions? All right, then let's add friction. See what we actually need to change here. I'm going to add friction on the left side only. So I'm not going to put friction in here. And what I want to know is, what is the coefficient of static friction so that this is in equilibrium? Actually, I can do better than that. What is the minimum coefficient of static friction? So system is in equilibrium. So as we work our way through what we've done already, how do the force diagrams change? Or do the force diagrams change?
You said you made only the left side frictions?
Correct.
Do we add friction to the right side?
No, we would not add friction to the right side since there's no friction over there. I only added to the left side.
Oh, you added to the left side?
Yeah, okay, we're out of sync right now. I added friction to the left side. That's why I put the mu is not 0 over here.
Not 0. See, that makes sense.
Ah, okay.
So the opposite of what I just
Okay. So we had friction over here. So which way am I drawing the friction arrow?
said.
That's it. You said down? Okay. So I add friction right there. I know it's static. And the right-hand side, there is no change. So over here, to the coordinate system is not going to change. I guess if it's in equilibrium, you could, but let's not bother. Decomposition, do we have to break friction up into its components?
No.
No. And it's in the negative I hat direction for A. So the equations of motion, what changes over here?
Would subtract, you would subtract friction from the I-hats of A.
Okay. So when we do the substitution phase, this is when we would put in the equation for friction, because there is an independent equation for that. What is the equation for static friction?
U sub S times the normal force.
What goes in between them?
Less than or equal to.
All right, So we have the static friction is going to be less than or equal to. Now, when trying to find the static coefficient of friction, we need to, backing up, when we're trying to actually find the value of the static coefficient of friction, we're looking at an extreme here. So because I know that if we're picking the maximum static coefficient of friction, it could be any huge number to keep it from sticking. So if I'm at a minimum static coefficient of friction, then I'm looking at a maximum static friction here. And what I'm getting towards is, when I make the substitution here, I'm just gonna look at the equal part of it. So this becomes plus mu sub s, which is what we're trying to find, times y sub a. So this stuff over here, we can get rid of. And probably gonna be easier to just go to a new screen. Yep, that's the one. So we had tension minus MAG sine theta A minus mu s y sub A is equal to, what is it equal to? For this new problem.
Command equilibrium should equal 0.
Equilibrium is acceleration is 0. So then our second equation was y sub, wait, no, I decided to be obtuse there. All right, or abstruse. So we have MAG cosine theta A minus y sub A equals 0. And then down here, MBG sine theta B minus the tension is equal to 0. And y sub B minus MBG cosine theta B equals 0. At this point, you solve. Because we have friction here, this equation now becomes important. I can solve for y from A and plug into there, so my top equation becomes the tension minus MAG sine theta A minus mu s times MAG cosine theta A equals 0. This equation, this one is not going to make any difference here because there's no friction on that side and there's no acceleration in that direction. And so we have MBG sine theta B, just rewriting that equation, minus the tension equals 0. And now we solve. We're solving for mu sub s. If I add the equations together, my tensions cancel out again, which is very convenient. And I'm left with MBG sine theta B minus M theta B. MAG sine theta, I lost my A there, sine theta A minus mu s MAG M sub A G cosine theta A equals 0. And now it's an output problem. Solving for mu sub s, I take it over to the right-hand side and then divide by this, and so I'm left with MBG sine theta B minus MAG sine theta A divided by MAG cosine theta A. Dramatic pause for questions. The numerator is the same thing as it was in the previous one, so that was 23.59. So this would be 23.59 divided by that. So 50 times 48-ish, just shy of that. 47.8. It's always tough to tell me what it really is. No, that's not right.
39.13.
Yeah, off by 10. 39 point what?
13.
So use of S, that minimum use of S so that it's in equilibrium is
0.60.
0.60.
Yeah.
What are the units?
Meters is second.
No. All right, let's take it bit by bit then. All right, what are the units of sine of theta? Theta is either degrees, radians, gradients, or a couple things, but the sine of an angle, what are the units of that? Say it again?
Meters.
No, not meters. Remember that the trig functions are just ratio of sides. So if sine is opposite of hypotenuse, so if my opposite side is 4 meters and my hypotenuse is 5 meters, what would be the units of the ratio?
It'd be meters.
So is 4x divided by 5x equal to 0.8x?
Are there no units?
Sorry?
Are there no units?
Yeah, this is unitless. This is just 0.8. All right, so the units of the trig functions here, it's unitless. So now what we're left with here is this MBG. What are the units of MBG?
There's not.
Oh, there are units of MBG.
If it's
I'm hearing sounds, but I'm not hearing people loud enough to understand it. All right, what are the units of mass?
grams or
We're cool, kilograms.
kilograms.
Units of little g?
Meters per second squared.
Units of mg?
Kilogram meters per second squared.
I think you would have written it down correctly, but the way you said it, you left the word out.
Kilograms per meter per second squared.
Ooh, put one too many words in.
Kilograms times meters per second squared.
There we go. I heard you say kilogram meter second squared. I missed the per. And then Louis put in 2 of them. All right, yeah. Kilogram meters per second squared, which is also known as it's a Newton. Remember, mg is just the weights of force, units of newtons. It's also, g is an acceleration, mass times acceleration is equal to force. All right, so the units of this whole term here is newtons, the units of this whole term here is newtons, unit of this whole term here is newtons. Yep. Back to this. If you think of units as like a variable in terms of solving, if I had 3x minus 2x over 4x, what does that equal to? It's open to anyone. It says-
1/4. 1/4.
Yeah. So if I have over there, if I had 3 newtons minus 2 newtons over 4 newtons, that would be.
1/4.
So what are the units of this 0.6? It is indeed units. Yeah, the coefficients of friction are as units, just like trig functions. All right, we're on a roll. Juice is flowing. We got the preliminary stuff out of the way. Questions?
Whenever you combine the two equations, is that why, so they, normal force canceled out, and that's why normal force?
The tension canceled out. You talking about combine these two?
Oh, I was looking at the wrong, that's why.
I just did this one to find the normal force so that we could plug it in right